everybody, welcome back to another fun and exciting pre-algebra class. Today we are going to be in lesson 4.4 in your books. If you're using a book, please turn to page 158. 158. We are going to be graphing today. What does it mean to graph? Well, it means to basically kind of make a picture representation. We've done, in other classes, maybe we've done bar graphs or circle graphs or pictographs. Graphing is just taking information, data, okay, and it's putting it onto a piece of paper kind of in a picture form. Now, we're not going to be really drawing any pictures today. We're going to be doing what's called line graphs. So basically, we just draw a line. It's called a number line. And, 0 is typically in the middle of your number line, and then we're going to put some other points on there. And we're going to take things and we're going to put them onto the graph. Okay, so it's going to be something different, but it also says there the title graphing inequalities, not equalities. What's the difference between an equality and an inequality? Well, an equality means it's equal to. Okay, so x equals 3. We've been doing that with equations and equalities. So that makes sense, right? X does equal 3 if that's what, indeed x does equal. But we can also do things to where x does not equal 3, x is less than 3, or maybe x is greater than 3. And the first one up here at the top that I want to show you is this one right here. X equals 3. Again, that's something that we've been getting. This is an equality, right? That's equal to. So what you would do is on a line graph, if you want to say x is equal to 3, is you would come over here to the number 3, right? Okay. And so you come over here to the number 3, and you would put a circle on the number 3. Now, to signify that it actually is included, it is equal to 3, we would actually go ahead and color in that dot on the number 3. Whenever you color something in on the graph, that means that it is included. So this graph right here would show that only the number 3 is included in our solution. In other words, the only solution to this problem is the number 3. Okay, so maybe that's you have to be 3 years old, maybe to be in a certain class or something in church or Sunday school. You have to be a 3-year-old. Nobody younger can be in the class. Nobody older can be in the class. You have to be 3. Well, that's what this graph would show right there, that only 3-year-olds are allowed in that class. All right, now look here at the next one. In this case, we have x is less than 3, okay? So now 3-year-olds are not included in the class. You have to be younger than 3. You can't be 3, okay? Maybe it's the nursery. So as soon as you turn 3, you have to go to the next class. How would we represent this? Well, we go to the number 3 and we circle it. Do we color it in? No. Why not? Because it's not included. If it were included, we would color it in like we did up here, but it's not included. Now, this isn't really going to make a lot of sense with the illustration of age, but what we would do is we would include anyone younger than 3. Now, technically in math, this is going to keep going into infinity. We know real life you can't really be negative 1 years old, okay? But in math, you can have negative numbers, right? We've already learned about negative numbers. So in this case, we would circle the number 3, right? Not color it in. Why not? Because it is not included. 3, it has to be less than 3. Now let me show you how this works. Let's like test a point. So just pick any number you want down here. It doesn't matter what number. Let's pick the number 0, okay? So if I substitute 0 for that x, that should satisfy or meet the qualifications. What do I mean by that? So instead of x, write 0 is less than 3. 0 is less than 3. Is that true? Yes, it's true. So this is correct that we colored in that side of the number line. Okay. Now, look down here at this one. This one means that x is greater than 3. Let me show you something real quick about less than and greater than, okay? So here's something that's kind of neat. I like this. I've always thought this was kind of cool. The symbol, okay, it always eats the bigger thing, all right? So in other words, if we put teeth on this thing, right, it's eating the bigger number. So if x is less than 3, it's eating the bigger number. So in this case, it's eating, put the teeth on there, it's eating the x. Why? Because the x is greater than the 3. In this case, the x is less than the 3, so it eats the 3 because the 3 is bigger. And, you know, I've seen people draw like a Pac-Man or some kind of a face on that, so it's, you know, it's eating the bigger number. You do however you want. Another way that people remember this is that this is the left. This arrow points to the left, right? So less and left, right? They both start with the letter L. So maybe you could remember that less than points left. Doesn't work with greater than because greater than doesn't start with R. So greater than points to the right. So, you know, greater points right. And so maybe that helps you. Less than points left, greater than points right. However you need to figure this out, but you do need to figure it out. It is very important that you understand the difference between these two symbols. That is a less than symbol. This is a greater than symbol. Okay? All right, so let's go down to this next one. Next one, we have the idea of x is greater than 3. So what we would do is, again, we would put our circle on the number 3. Do we color it in? No. Why not? Because 3 is not included. It's greater than 3. So again, try a point. You could test either one. Let's test down here. Let's test 0. 0 is greater than 3. Does that make any sense? No, 0 is not greater than 3. So let's test a point from up here. Let's test 5. 5 is greater than 3. Does that make sense? Yes, it does. So which way is our line going to go on this one? Our line is going to go up on this one, okay? So that one is greater than. Now, check out this next one. This next one says that x is less than, but then look at this little thing right here. That is less than or equal to. So in this case, this is like, okay, all 3-year-olds and younger. So the 3-year-olds would be included in this class at church because they are 3 years old. Or anybody that was 2 or 1 or 0. I guess you could be 0, right? So the first 12 months of your life, you're actually 0 years old, okay? All right, so anybody that's younger than 3 would be included. So the way that you would graph this is you go to the number 3 and you circle it. Now, think about this. Go back up here. Remember when it was equal to? Remember what we did when it was equal to? We colored it in, didn't we? Right? So what do you think we're going to do here? We're going to color it in. Why? Because it's equal to. It can be equal to 3. So we color in the number 3 here. This is called a closed dot. Okay? Closed dot. This is called an open dot. Right? So that makes sense. If it's open, all right, so it's not colored in. If it's closed, it's colored in. So we close the dot because it's equal to, but we still have to deal with this. It's still less than 3. What does that mean? Well, less than 3 means that it goes over here to the left side. Now, how do we verify that it actually does go to the left? We substitute something in. So -2 is less than or equal to 3. Yes, that is true. Okay, so you always can verify or check by substituting in. All right, next, let's do this one. Now we're going the other way. Now we're going to the right, so we have a greater than. We still come to the number 3. This number 3 has a name when we're graphing. This is called a critical point. So what you do is you graph your critical point. In this case, my critical point is my 3. In other words, that's the important part, right? So look at this graph right here. The 3 was the critical point. That's the important point that we need on the graph to know what's happening. So we're going to graph our critical point. So come over here, and our critical point is 3. So we're going to graph our 3, put a circle around it. Notice it is also included in the answer, so we're going to color it in because it's also equal to, and it is greater than, so these numbers are greater than 3. And then you just test one. 5 is greater than or equal to 3. Is that true? Yes, it is. So we did it correctly. Okay. All right. Here's one more. This one is not an inequality, really. It is just not equal. Okay, this one means that it is not equal. So there is nothing. So in other words, there's no solution, or maybe there's lots of solutions except for the number 3, something like that. So in this case, if we get it is not equal to 3, so maybe anybody except for 10-year-olds are involved in this. So anybody in the school, unless you're 10 years old, I don't know why we're excluding 10-year-olds, but, or in this case, a 3-year-old. 3-year-olds are excluded. They can't come to class. I don't know why. They've been bad. I don't know. All right, so the way that we would do this, we would just come down here to the number 3, and we would circle it. Is it included? No, it's not equal to, so we would not color it in. Now watch this. On these ones, we color in both sides. Why? Because anything works. For example, let's use the number 0. 0 is not equal to 3. Well, that's true. Let's try the number 5. 5 is also not equal to 3. Yes, that's also true. What's the only one that doesn't work? This one right here. 3 is not equal to 3. Well, no, that doesn't work. So to show that on the graph, that's where we put this little bubble around the 3. We say that one, it's not included. Everything else that's colored in here, all of these other numbers. Notice this little arrow right here, right? And this little arrow right here. That means all the way into infinity, those numbers are also included. Any number all the way up the number line or all the way down the number line. The next thing that I want to do is I want to show you how to do what's called compound. Compound. So what does compound mean? Usually in English, right, compound means more than one. Okay, so this is compound. This is more than one. So look what we have going on here. We have more than one inequality. You really do them the same way. There's not much going on here. Here's what you do. You take your first critical point, -5. So go over here to -5 and you circle -5. Now you look, is it included? No, it's not included. Then you come over here to your next critical point and you circle the number 2. Now you ask yourself, is it included? Yes, it is. So on the number 2, we would color it in because of this little guy right here, this equal to sign that's underneath there. So we would color that one in. Now, here's the question. What else do you color in? So do you color in down here? Do you color in up here? Do you color in the middle? Well, here's the way you figure that out. Here's the way you determine, well, what else do I color in? Pick a point that's in between the lines, okay? If that point works, then you color in the middle. If that point does not work, then you would color in on the outsides. Or you could test a point on the outside too. But let's test this middle point. -5 is less than 0, and as 0 is less than or equal to 2. So just read it. Is it true? Is 5 less than 0? Yes. Is 0 less than or equal to 2? Yes. So 0 works, right? So what would we do here in the middle? We would color in the middle, right? So everything in this middle area works. Now, does the number 2 work? This is an interesting question. Does the number 2 work? Yes, it does. See, because if we put 2 here instead of the 0, -5 is less than 2. Yes. and 2 is less than or equal to 2. Yes, 2 is equal to 2, so 2 works. So 2 is colored in. Does -5 work? No, it does not. That's why we didn't color it in. Okay, so -5 is not less than -5. Okay, so that's the way that those work. Let's try one more. So if I have 0 is less than or equal to x, which is less than 4, graph your critical points. Here's a critical point at 0. Let me just circle 0. Do we fill it in? Yes, we do, because that is also included with the little line that's underneath of it. Go to 4. That's our next critical point. We're going to circle 4. Do we color 4 in? No, we do not. Why not? Because it's not included. So now we see, is it the middle? Let's try the middle again. A lot of times it's going to be the middle. Not always. Don't count on it being the middle. Okay. So let's try 2. 0 is less than or equal to 2 and is less than 4. Is that true? Is 0 less than or equal to 2? Yes. Is 2 less than 4? Yes. So we would color in this middle area. Okay. So that's how we do that. Now, let's quickly say, well, what if they just give me a graph? Okay. Can I make an equation or an inequality from the graph? Yes, you can. How do you do that? Take and you say x, okay, because that's our number that we're trying to figure out, is what? We would look at our critical point. 0 is our critical point. Which way does this line go? This line goes to the right. So we would say that x is greater than 0. We would put our arrow the same way that the line is going in that case. Okay? So x is greater than 0 looks like this on the number line. Now, notice that this is filled in. So what does that mean? That it's not just greater than, it's also greater than or equal to. Because in this case, it can be 0. How do we know that? Because we have a closed dot. Okay. Next, let's try this one. This will be the last one. So this one is a compound. Notice we have 2 critical points. Put your first critical point, put your x, put your next critical point, then we'll fill in the signs. So what's our first critical point? 1. Then we put our x, and then we put our next critical point, which is 3. Now we can fill in our signs. Notice that from the 1, we're going which way? Okay, now this is a little interesting right here, so you do have to be careful. So the x goes right here. So in relationship to the x is in the middle, right? Okay, so don't go to in relationship to the 1 or in relationship to the 3. Go in relationship to the x, okay? And that's why this is going to be just a little bit weird, but hopefully you can kind of wrap your mind around this. Which way are we going here to the 1? Well, we're going to the left. So our inequality is going to go to the left, right? And then it's also going to be or equal to. And here we're going to go in relationship. You can go in relationship to this x. Well, the x is less than the 3, right? So if 3 is here, then the x is left of the 3. So you're going to put the sign going to the left, okay? And then that's right. That's what you have. That's your inequality. 1 is less than or equal to x, and x is less than 3, okay? Lots of information there. Packed a whole bunch into that lesson, maybe a little bit longer than I would have liked it, but we try to get it all in. That way we don't have to teach this lesson on 2 different days, right? Get it all into one so we can be done with it. All right. If you missed anything, scroll it back, rewind it, and watch it again. We'll see you later. Have a good one.